There are 8 known planets in the solar system, but for a while, there has been some evidence that there could be one more, a hypothetical planet 9 lurking at the outer edge of our solar system. So far, this world has eluded discovery, but a new study has determined where it should be. The evidence for Planet 9 comes from its gravitational pull on other bodies. If the planet exists, its gravity will affect the orbits of other planets. So if something seems to be pulling on a planet, just do a little math to find the source. This is how Neptune was discovered, when John Couch Adams and Urbain Le Verrier independently noted that Uranus appeared to be dragged by an invisible planet. In the case of Planet 9, we do not have any gravitational effect on a planet. What we do see is a strange grouping of small icy bodies in the outer solar system known as Kuiper Belt objects. If there were no planets beyond the Kuiper Belt, the orbits of the KBOs would be expected to be randomly oriented within the orbital plane of the solar system. But instead, we see that many KBO orbits are clustered in the same orientation. It is possible that this is just due to chance, but that is not likely. In 2016, researchers looked at the statistical distribution of KBO and concluded that the clustering was caused by an undetected outer planet. According to his calculations, this world has a mass of 5 Earths and is approximately 10 times more distant from the Sun than Neptune. The document even calculated a wide region of the sky where the planet could be, but the searches turned up nothing. This led some to conclude that the planet does not exist. Orbital rarity does not prove that a planet exists. Ask Planet Vulcan. Others went so far as to argue that Planet 9 exists, but we cannot see it because it is a primordial black hole. This new study re-examines the original work in light of some of the criticism it received. One big criticism is that the outer bodies of the solar system are hard to find, so we look for them wherever convenient. The clustering effect we see could simply be due to skewed data. Taking into account observation bias, the authors find that clustering remains statistically unusual. There is only a 0.4% chance that it is a fluke. When they recalculated the probable orbit of Planet 9, they were better able to pinpoint where to look. An interesting aspect of the study is that the newly calculated orbit places Planet 9 closer to the Sun than was originally thought. This is strange, because if it's closer then we should have found it by now. The authors argue that observations so far have ruled out the closest options for Planet 9, helping to further narrow down its possible location. If the planet exists, it should be detected by the Vera Rubin Observatory in the near future. This study is not conclusive and many astronomers still maintain that Planet 9 does not exist. But this study makes it clear that we won't have to argue about it much longer. Either it will be discovered soon or observations will dismiss it as an explanation for the clumping effect of KBO.